Well, greetings students, good to be with you. Today we're going to be doing the drill tap bore plate. I'm going to show you how to machine this in Mastercam 2026. We have done some previous parts in Mastercam 2026. This will be a little more involved because of the machining of the bore through and a counter bore and such. So we'll get started with this right now. You'll notice here that I have my levels up here and in view, and you'll see that I have geometry and dimensions, and my dimensions can be eliminated just by clicking on this little eye up here, and so you should have your layers separated. Geometry, dimensions, and all your other layers, they should be deleted after you have moved everything to the first layer. So that's where we are right now. I'm ready basically to create the Cartesian coordinate in Mastercam and blend it with the reference point in the drawing, which is the lower left-hand corner. So in order to do that, I need to go to Transform up here, and I'm going to make sure that everything appears though when I do this so my dimensions don't get moved out in space. And I'm going to say move to origin, and right away it says select the point to translate from, and I'm going to pick this point, lower point right down here, left click on it, and you'll see that the drawing disappears because it's moved now with the Cartesian coordinate out in space in Mastercam. To bring it back in, I just simply need to right click here and say fit, and it brings everything back. I'm not crazy about the magenta color, so I'm just going to draw a box around this. Left click, draw a box, and I'm going to right click and space out here, and I'm going to go where it says clear options, and it'll bring it back to the white color. And then I'm going to save this basically, so I'll say File, Save As, and I'm going to put this right in your files, CNC1 2025 students, milling DXF files, and make sure that it says machine here on the bottom, M-A-C-H, and hit OK. So now that's there. If I open this up, you will see that file appear. What it immediately does is it moves it into a Mastercam file. Okay, so we're going to get out of that and we're going to get started with this now. We got our Cartesian coordinate where we want. I'm going to cause the dimensions to disappear for the moment so that we can see where we need to put our stock and so on and so forth. And then I'm going to bring up toolpaths. Lower left hand corner is the toolpaths, and in here of course we already are familiar with using this in creating the necessary simulations and so on. So at this point I want to create my stock and I want to pick a machine, so I'm going to go up here to machine and I'm going to choose mill, but I'm going to drop this down and make sure I choose default. And then I'm going to get some menu up here. I'm going to have machine group 1. If I expand this, I'm going to have machine, master model, stock setup, and so on. We will need to go through these to make sure that we have everything in place. So let's start with machine, and when that file comes up, there's mill default here, which is what we chose, and where the files are, where that is found. The housing is already checked off. You can leave it checked off. That really doesn't pertain to us right at the moment. These are default. Operation comments is also checked off, but it's default. And down here we have program numbers. So I'm going to put the program number down here. I'm going to say 125. You can choose whatever you want. And I'm going to start with 10 being my first increment. And then I'm going to go increments of 10 after that. So N010, N020, and so on. And when I'm done that, I'm going to go to the next category, which is the master model. And there really isn't anything much to do here. You'll see that default is aluminum 2024. It's really not going to change anything, so we're just going to leave that alone. And then we're going to go to our stock setup, which is about the most important part of this whole thing. So we want to go to isometric here so that we can choose and make this a 3D view. We're going to choose, as I said, we're going to choose rectangular stock, okay? And it's going to ask us to select the areas we want to create our stock with. So I'm going to get down here to the lower left-hand corner, pick that, pick this, pick this, pick this. I'm going to say End Selection, and then I'm going to see that the origin comes up. Just disregard that. That's showing the origin being in the middle of this, which is not our origin. Our origin is over here. So we need to create our origin at the lower left, so we're going to do that right now. We see that there's 8 inches already there for us. It's 2 inches this way. That's already there for us. We just need to make sure that we have this push-pull activated here and incremental activated, and we don't want to check off both directions. We only want it to move in one direction, and that is down, so that we have our geometry still in front of us. So at this point then we can put in a value then for the lower, and we know that the part is 1.0 thick, so we're going to put that in there, and we'll click out here in space, and you'll see immediately it creates a solid, but it's a simulation solid, just so you know. And so that's finished now. We don't have to do any more there. We can move to the work holding category. There really isn't any work holding here. We don't have a machine or anything that we're putting this in, so that's not really necessary. And then we go to Tools, and in Tools, we want a feed calculation based on from the tool. And down here at the bottom, we want to make sure we say assign tool numbers sequentially and warn of duplicate tool numbers, okay? So those things are essential. And then after we're done there really isn't nothing to do in the simulation, so we're just going to hit the green check mark, and you're going to say, well, what happened to our stock? Well, it's easy enough. Under File, up here you pick Stock Display, and if I go to Isometric, you will see that it shows basically a wireframe stock. If you like the shaded stock, you just simply click on Stock Shaded here, and now you'll see a representation of the stock of the material. Of course, there really is no extra stock on the width or the length or the height because we're just going to go off of normal size, everything being exact. All right, the next thing we want to do is create some tools. So the first one we're going to create is going to be, we have this, if we go down here to levels, we can click on levels and click on dimensions, and we'll see that this is a 5/16 18 by 500 deep tapped drill, a drill and tap hole, and there's going to be 12 of those. And we will have to find a drill for that, and also find or create our drill and our tap for that. Okay, so we're going to go ahead and do that right now. I'm going to basically uncheck this now at levels and disappear, so we can go ahead and get started with it. Under Tool Manager here, you're going to see this files, these drag and drop files here, and we're going to go ahead and put our tool filter on here, and we're going to be looking for the center drill first. So we're going to say none here so that nothing is highlighted, and then you will look for the center drill, and then you will say OK, and you will see the list of center drills. I'm sure you're used to this already. We've already done this before, but I'm going to left click and drag this up to the top so that I have my number one tool up here. The next thing I'm going to do is to pick our tap drill, and since it's 5/16 18, I'm going to pick a 257 drill. So I'm going to go back to our tool filter. I'm going to say none, And then I'm going to be looking for a drill category, which is right here, and say OK. And then I just need to scroll down here and look at these dimensions here. It's a 257, and carefully look for it, and right there it is. It's a letter F, and we're going to drag that up here and put it in place. And we're just going to keep going. We're going to try to create all of our tools here if we can right now. That way we don't have to worry about it later. Again, I'm going to click Tool Filter, and we're going to be looking for a tap this time. So I'm going to say none here. I'm going to be looking for a right-hand tap, and I'm going to say OK. And then I just need to scroll down here and look for a 1/4-20, or 5/16 18, I'm sorry. 5/16 18 tap. And I'm seeing one right here. And I'm going to drag that up here. So now we have the tools to do the holes. We have our center drill, our letter F drill, and we have our 5/16 18 tap. All right, so we're good there. Now, for doing the bore through and doing the counter bore, we're going to choose a 1/2 inch end mill. So I'm going to, again, hit the filter. I'm going to say none here. They all disappear, and I'm going to look for a flat end mill. I'm going to say OK, and then I'm going to scroll down here and look for a 0.500 1/2 inch end mill. Flat end mill, and I'm going to drag that up there and put that right there. So now I'm going to be needing some, I need to go over these just like you did in a spree. You have to go over these and see if everything is the way it should be. Looks like our tool numbers are 1, 2, 3, and 4. That looks good, but let's go into the center drill here and pick that first and take a look at this to make sure that everything is correct. It should appear like this. Then we're going to go to this category here, and we're going to look for the number 3 center drill. And I click on that. It's always going to ask changing the standard size. We're not changing it. I'm just going to say no here. And then all the values that were put in there for that number 3 center drill will show up down here. Your drill diameter, your distance of the pilot, 118, 60 degree, all of those will appear, and your cutting length and your shank diameter and your overall length are all good here now. Then I want to check with this first one, which says the tool number, and this is where you put in your tool number, but as I already said, it looks like the tool numbers are correct. It should be tool number 1, length offset 1, diameter offset 1. And then we can go to the next one, which is going to be, and our final one here, is to pick what kind of material the tool is. It is high-speed steel. We want to go in a clockwise direction. We're looking for 2,000 RPMs. We're looking for a retract rate of 50, a plunge rate of 25, and a feed rate of 20. Now, as I said before, the plunge rate is when it comes down in rapid traverse or something close to rapid traverse down to Z0 or Z100 in this case. So we have everything we need here at this point. There's nothing here that we need to fill out in this area here. So it has already revised the feed per tooth. It has revised the surface feet per minute for the tool itself. So we're going to say OK on this, and the holder here we'll deal with later. So we're going to hit OK again and go back to our next tool. All right, our next tool is the drill, and we're going to move down here and look for a 257 drill. Again, you can be looking over here at the column where the diameters are to get there, get close. So it looks like I'm pretty close right now, 204. Looks like we have like a 257. Heavy duty taper, no. Heavy duty screw machine, no. F screw machine, no. And here's jobber. We're looking for a jobber. And we're going to say no here again. And so all of the dimensions for this are here. 257, 3-inch overall, 2-inch. And this is basically taken off of an actual jobber's length drill. So we shouldn't have to change anything here at all. Everything should be good. And now we'll go up here to make sure our tool number is correct, which it is. Letter F drill, US. That's good. Now we go down here to the third category, which is going to be our basically speeds and feeds. So we're going to say that the spindle speed for this is 2,000. I'm sorry, 1,200. 1,200. And our retract rate can be 50. And our plunge rate will be 25. And our feed rate will be 20 point. Nothing needs to be done down here. Looks like everything's okay. One other thing I wanted to check to make sure that the tool is okay. There's no category for that. It's accepting the fact that it's high-speed steel. And I'm going to say okay, and the holder is going to come up, and we're going to say okay for now. We can change that later. So we're going to do the same thing for the 5/6/18 tap. We're going to say that it's tool number 3, offset 3, right hand. Okay, make sure that's all good. And everything looks good here. And then we want to pick that tool in this drop-down file here. 5/16/18 right there. And all of our values should be in here for it now. And it looks good. I'm going to say that this is a plug tap though, because a plug tap is a spiral point. We've been talking about using those for blind holes. So we're going to change it from bottoming to plug, and it's going to adjust the length a little bit for us. Then we'll go back here to speeds and feeds, and of course we know that we have a calculation for this. Whatever you choose for a speed, say it's 300 RPMs, you have to multiply that times the pitch. So you'll take your calculator and you will put in there that it is 5/16/18. And that's 0.055555. So it's already given that to you up here. So we're good with that. It already knows what that is. But remember, we said that you take your feed, your pitch, and multiply that times the speed. So you want to make sure that whatever comes up here for a feed rate, that it would be correct for that speed. So, okay, I'm going to go down here and say that it is a high-speed steel tap, and I'm going to say that my spindle speed is going to be 300. I'm going to say that my retract rate is 50. I'm going to say that my plunge rate is 20. And I'm going to let this calculate what it should be. And it's 6.66666 feed rate with a 300 RPM speed. All right, so if you want to check that, you can, and I'll check it right now just to make sure we have that good. And we're should say 16 points. There it is. 16.6 was what I got. So that's correct. All right. So that's there for us. And we should be able to say OK here now, and OK again. And we can work on our last tool, our 1/2-inch flat end mill. All right, our 1/2-inch flat end mill then is here for us to look at. We're not going to get the same kind of categories here as we did with the drills and stuff and taps. So it's here, we're basically going to get our categories right here. The cutting diameter is 1/2. The overall length is 3. The cutting length is 1. And we can change some of these things. So I'm going to say that the cutting length is 1.5. And the overall length can still be 3. The cutting diameter is still 0.5. And I want to make sure that I check off no corner. So there's no radius on this, okay? So shoulder length, 1.5. Shoulder diameter, 0.5. Shank diameter, 0.5. And it's a straight type of an end mill. And everything looks good here. I'm going to say OK. But before I do, we need to go to our parameters here and make sure we pick our spindle speed. And my spindle speed here is going to be 800. My retract rate is going to be 50. My plunge rate is going to be 20. And my feed rate is going to be 15 point. Okay? It's high-speed steel, going clockwise. Nothing is needed here. This is going to be, except for the fact that it's going to be a roughing and finish tool in this case. If we were doing this in real life, we'd probably have a rough tool and a finish tool. But at this point, just because it's a tutorial, we're just going to use the 1/2-inch for both. And let's see, everything looks good right here. So at this point, we're going to hit OK and hit OK again. And now we've got our fourth tool taken care of. All right, so we can get rid of that tool manager file, and we can begin with putting in our tapped hole locations and get started with a drilling operation. So I'm going to go back to toolpaths now. I'm going to go up here, and at the right hand corner of this my toolpath drop down, I'm going to right click and say drill. And immediately there is a file that comes up, and it's asking me to pick the holes. Well, in order to do this properly, we have to hit the top view and zoom in on the top view to be careful we get into the center of these crosshairs. Very important. Lots of times you pick the end of the crosshair, and then it puts the drilled hole on the wrong location. So I would suggest that you can start right down here at the bottom, and you can just hover over the center of that crosshair until you see a green crosshair there, and left click on it. Then come up and do the same up here till you see the green check mark, 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 and so on. You have to take your time with this. This is not something that you want to do quickly. You don't want to have to go back and start over again or have to reverse it. All right, so we have those all taken care of at this point. We still want to do the 3 in the center, just to make sure that we also center drill that. And finish that up. So that's good. That will be our chain for our center drill. I look at this over here now and usually just try to make sure that it did capture everything. It looks like it has everything captured. Everything looks good here. I'm going to say OK. And then you're going to get the actual pec drill file coming up. All right, so it's tap tool. The tool path is a drill. You see this is grayed out already for you. The tool we're going to pick is our center drill. All right. And our holder will come up next, and we'll choose, let's say, a holder that looks a little bit better. And I'm going to try to choke up on this. Sometimes it doesn't let you, but I'm going to say 1.5 here and hit enter, and it lets me choke up on it, which is good. We don't really want to click on stock, but we do want to click on cut parameters, because this is where we're going to be doing the actual operation itself. As you see here, there's drill counterbore, there's pec drill, there's chip break, and tap. We need the drill counterbore. G81 is just a one-shot drill operation, and that's exactly what we want. Then we want to come down here to linking parameters. You don't want to do any tool axis control or limits or whole segments at this point. So just come down to linking parameters, and you want to immediately make all of these absolute. Absolute and absolute. And then we're going to go up here, and our retract is going to be 0.100. The top of the stock is 0. And the depth we want to go with this is minus 0.200. As we discussed in class, in Mastercam, you have to put the minus value here, or it'll be cutting out in space. Then, the next thing we want to do is go to the coolant to make sure that the coolant is on. Make sure that's on, and it is on, and then we're going to say OK. So now we can put this on isometric here, and we can go down here and do basically a plot of this. And I'm going to click on this and let it go through the operation for me. Okay, looks good. So if we wanted to actually look at this in simulation, we can go up here to Machine Group 1, and we can click on Verify, and it'll verify this for us. So our verification screen comes in. We can slow this down a bit, and we can go ahead and see what this looks like. So now we can zoom in on this and see that we have our holes about the right depth. You can also click on simulation too, which will give you a little crisper type simulation of this, and you can again slow it down a bit, and you can click on this and it'll do the same operation as before, but it'll just look a little more distinct. And if you look at it now, it looks a lot cleaner. All right, so enough there. If you don't want to have your tool be visible here, again, you can go to Tool Components and you can check off Holder, and it'll disappear if you don't want to see the holder itself. All right, so we'll get out of there. And now we want to do our drilling operations for the 12 holes. And again, they're going to be about somewhere around 800 deep. So I'm going to have to create a new chain for them, because I only want the 12 holes to be for that to happen. So I'm going to go up here and right click on the top of this, the top of my toolpath bar, and I'm going to click on drill. And this time I'm going to again choose the top view. And I want to pick, again, the holes that are just the ones I want to drill with the tap drill. So I'm going to wait. I'm going to start down here, I guess, as I did before. Wait till I see the green arrow, and go through this and pick all 12 holes. Sometimes you have to click off of it and come back to make sure that you get the center. And I'm going to check these out again. They all look good. I'm going to say OK. And now I'm ready to go ahead with the drilling operation itself. So it says drill here. Our tool is going to be the letter F drill. So we're going to pick the holder now, and we're going to see if we can choke up on this. I'm going to say 2.5. Hit enter, and it looks like it lets me choke up on it. Again, we want to skip stock and go to cut parameters. This time we're going to be peck drilling. So we want to pick peck drill operation G83. We want to make sure we have 100 thousandths for our first peck, and so on. Then we want to go down here to linking parameters. We want to make sure everything is okay here. Absolute, absolute, absolute. The retract is 100 thousandths, and our depth now is going to be about 850, so 0.850, to make sure that we have it deep enough so we can run our tap a ½ inch down and have somewhere for the chips to go. And at this point, we'll check just one more time the coolant, but I think it should still be on, and it is. And now we have created our drilling operation. And again, I got to go back in here because I see that the parameters here for the linking parameters, I have to have a minus 0.850. So I'm going to put minus there, fix that, and now I'm where I should be. I can check this out and do a quick back plot to make sure that it is going down inside. And I can zoom in and I can see that it's going down there about what it should be. All right, looks good. All right, so the final thing we want to do with the tapped holes, of course, is to tap them. So I can use basically the same 12 holes that I just chained for the tapping now. So what I can do here is I can right click on this and say copy, and then I could come down here, right click and say paste, and it'll move and it'll copy the peck drill operation. And what I can do is I can go in here to parameters and change this to a tapping operation. It saves time with not having to go through the whole routine again. So again, we have drill. Drill and tap are all under the same category. This time we're going to pick the tap itself, and we're going to then go to holder, and we'll pick a holder that is relatively good, and then I'm going to put in 2.5 and hit enter and let it choke up a little bit. And our cut parameters will be next, and this time we're going to pick tap, and then we're ready basically to do the linking parameters. So it's still 100,000, it remembers that. It also has down here minus 850. We don't want that. We want minus 0.650 to get our full thread. And our coolant should be good here, so all we have to do at this point is hit OK. And now we should be good with the simulation or the back plotting here. Okay, so everything's good there. I'm going to save this. You should save yours as well. And I'm going to sign off on this portion of it. When I come back, I will show you the balance of the work that needs to be done. Have a good day.